Prove the statements in 1 through 11. In each case, use only the definitions of the terms and the assumptions listed on page 161, not any previously established properties of odd and even integers. Follow directions given in the section for writing proofs of universal statements. For every integer n, if n is odd, then 3n plus 5 is even. Now here I have the list of assumptions that we can make from page 161. All right, so let's write our first proof. We start by titling our proof with the word proof. Now we're going to start by making some assumptions. We're trying to prove a universally quantified statement. We're going to pick an arbitrary integer n, and we're going to show that this property holds for the arbitrary integer, and because of the arbitrariness, we'll be able to prove that the statement is true for every integer n. So we're going to assume that n is an odd integer. The next thing we can do is we can explain what it means to be an odd integer. We have the definition of an odd integer, so we could say, therefore, by definition of an odd integer, n equals 2k plus 1 for some integer k. Now the goal is to prove that 3n plus 5 is even. So let's look at 3n plus 5. Well, what we could do is we can replace n with 2k plus 1. That's according to this third assumption here. We can use the principle of substitution. For all objects a and b, if a equals b, then we may substitute b wherever we have a. So here we have n. We also have 2k plus 1, but those are the same thing. And so when I write 3n plus 5, we could substitute 2k plus 1 into n to write this as 3 times 2k plus 1 plus 5. We could justify this claim by saying by substitution. Okay, so where do we go from here? Well, the goal is to show that this is an even integer, meaning that we can write this somehow as 2 times some integer. So now we have to do some algebra to rewrite this expression as 2 times some integer. What I'm going to do is I'm going to say then 3 times 2k plus 1 plus 5. We can use the distributive property to say that this is equal to 6k plus 3 plus 5, which is 8. And this is by the distributive property and simplification. Okay, so now we have 6k plus 8. What we could do is factor out a 2. So we could say this is 2 times 3k plus 8. So now we almost have what we want. We've almost simplified 3n plus 5 as 2 times this integer. The next thing we need to establish is that this 3k plus 8 is actually an integer. But why is this an integer? Well, because since all integers are closed under multiplication and addition, then 3k plus 8 equals m for some integer m, which means that 2 times 3k plus 8 is really the same thing as 2 times m, which means that my original expression, 3n plus 5, is the same thing as 2 times m for some integer m. But this is precisely what it means to be an even integer. We can write the expression as 2 times some integer. So therefore, 3n plus 5 is an even integer by definition of even. Now we can say that since this statement is true for any arbitrary n, we could say therefore, for every even integer n, 3n plus 5 is even, which is what we wanted to show. Thanks everyone, and I'll see you in the next video.